Okay, so you see a object is green because the green light is actually coming out and it's reforming the uh, part of the sensor array. So the colors are being perceived by humans, determined by the nature of the light reflected from the object. So same thing is occurs in our camera system too. Okay, so when you look at the images, right? So from electromagnetic radiation, you saw it occupying the entire region. You have, ultraviolet rays, infrared rays, microwaves, gamma rays, X-rays, and things like that. So we are in this region. So we have visible spectrum. Some a small portion of the visible spectrum. We have RGB here, for example. Now this is black, green, and red. So this is going to infrared region. So now combination of this is only being used for color images. The wavelength region is something like 400 to 700 nanometers, right? So within this region, now the combination of these waves, actually light waves, are basically used to interpret our images. So um, I mean, it's a nice region. So here you will not be able to see X-rays and other things, gamma rays. So here also this is a high frequency. So we will not be able to see some of them here. So now when you try to take the reflected electromagnetic waves back onto a sensor, you get into a number of imaging types. Okay, so photographs is what we are doing. We can also do infrared imaging or thermal imaging. Sometimes thermal imaging. So heat waves, a particular portion of the heat wave. Similarly, microwave imaging, we are doing ultraviolet imaging through telescopes, X-ray imaging, positron tomography image. So these are different portions of the electromagnetic spectrum that you saw. And now this is the region that we are very familiar with. Okay, so